All right, chemists, welcome to your second online lecture. This one's going to be pretty short. This is the lecture about conservation of mass. Goes along with the lesson you guys did about the copper cycle. I think I'll use this blue today. So one of the things you might have heard about, I think you talked about it in physics, is the law of conservation of mass. So what this says is that mass cannot be created or destroyed in a chemical reaction. So nothing we do in the lab here is going to create or destroy mass. So where we saw this is the Cu atoms, the atoms of copper, changed form, like they became part of a solution or part of a compound. They bonded with different things. But what started as copper, those copper atoms were still there the entire time. They were always present. Okay. Now, law of conservation of mass is going to hold true for everything we do here. Einstein's famous equation E equals mc squared shows the matter energy equivalency. That's only for nuclear equations, nuclear reactions, where you can get a small amount of mass converted to energy, a small amount of mass converted to a huge amount of energy. But nothing we do in this class, nothing we're going to talk about in this class, really will break the law of conservation of mass, so we can assume that's going to be constant all throughout. Okay, so basically, in walking through what we did in class, we started with solid copper powder. The nitric acid was added. We had this really poisonous gas that we let off in the hood. And then we had a blue solution, which is copper nitrate. So the copper atoms were then present in solution, dissolved in the water. So after adding sodium hydroxide, which we'll learn later is a base. And you don't need to worry about copying this whole cycle down. I'm just walking you through it. So don't bother copying this all in. After we added the base, we had solid copper hydroxide. The copper atoms were part of this solid substance. So again, you can tell from the S here, or the AQ, this is aqueous, this is solid. So like we learned in the last lesson, the AQ, the S, tells you what phase of matter it is. So we heated and filtered, and we got solid copper oxide, which was that solid powder that we had. Added sulfuric acid, which is an acid. We'll talk about acids and bases towards the end of the year. And we got copper sulfate, which was again a aqueous or a solution. So the copper atoms were dissolved in the water. When we added zinc, added solid zinc, we got back to where we started from, which was the solid copper powder. So all of these chemical reactions were done to show you that though the copper atoms were not created or destroyed in all of these reactions in the entire process, they just changed their form. So to wrap up, see, I told you this would be short. What we were studying is what happens to elements in a chemical change. Well, elemental copper can be transformed through chemical reactions and then recovered. And this is true of any material we use. That can be transformed but recovered. We can represent elements with symbols and keep track of them during chemical reactions. So the symbols we learned about in an earlier class are going to help us keep track of what's going on. And then elements combine and recombined but are not created or destroyed in chemical reactions.